Now in section 5 of chapter 6, we're going on to what are called special products of polynomials. Now we showed in the previous session the traditional way of multiplying, but there are, when you recognize certain factors, that you can multiply in a special way. And here they will review the FOIL method, then they'll review multiplying binomials and others where there are special products. Now, the key to these special products is that when we get to know the trinomials that result, undoing them lets us have a better view of how to factor them. Again, that's where we're going in the later sections of this chapter. We want to know how to factor, to get back to this once we do the multiplication. And they're going to show you, and I'm going to show you too here. So let's do some of this. So FOIL, what does that mean? Well, the first, the outers, the inners, the last. So as we look at a binomial, the first are the x and the 2x. Now the outers would be this x again and this 8. The inners would be the 3 and the 2x. And the L is the last, and it would be the 3 and the 8. So what you're doing is you're making all the possible combinations that you can get. Now often when students do this, and initially you may want to do something like this. They multiply the first. So you put a line like so. So this would be x times 2x is 2x squared. Now you're going to do the outers. So mentally you kind of go like so. The outers, x times 8 is plus 8x. Now the inners, plus 6x, and then the last, plus 24. Now, usually you have like terms in the middle that you combine, and you get 2x squared plus 14x plus 24. Now, at this time, again, it's a good thing to remember that you're going to take this and kind of move it back to this in a later section of this chapter. We're going to be able to factor this, in a sense, by reversing the FOIL. So, again, I don't think it's not useful, but I think it's very useful that we think of what we're going to be doing. So when it's in this standard form, what are our first terms that gave us this? Well, since 2 is prime, it has to be an x, let's say, and a 2x. And then we say, what term gave us this 24? Well, we know it was a 3 times 8. And when we added these together, our inners and an outer, it had to add up to 14. So we could try a 3, let's put an 8 there, I think works better. And sometimes you have to, fiddle around with these to see what it is. So this is going to be an 8, your outers. This is going to be a 6, your inners, and they add up to this. But again, I'm getting ahead of myself. Right now, we're just practicing the FOIL. And this is what the book shows. first, outers, inners, last. Like terms in the middle, and there's our answer. Now, again, as you practice this, first, outers, inners, last. First, there's your 6x squared. Outers, negative 10x. Inners, I really like the way they're showing this, a negative 9x. And notice what they're doing here. They're kind of putting the like terms vertically. And then your last, a 15. And notice, thinking of this mentally, this is going to add up to a negative 19x as you combine like terms. Now, another special kind of FOIL is this. Now, just study this for a moment. Here we have an x plus 7. Here we have an x minus 7. So these are the same terms, but just different signs. So we often describe this as the product, because you're multiplying, of the sum and difference of the same terms. Now, these, the way they're set here, have a special relationship. They are called conjugates. I want you to write this word down. Probably one of our quiz questions. So what are these binomial factors called, where they're the sum and difference of the same terms? They're called conjugates. And we often illustrate it this way. A plus B, A minus B. So as you FOIL this, you get an A squared. Your outers, a negative AB. Your inners, a positive AB. And your last, a negative times a positive, give you a negative B squared. So what happens to your middle terms here? Well, they cancel out through subtraction. And you're left with A squared minus B squared. Now, this has a special name as well. This is called the difference, because of the negative sign between them, of perfect squares. Now, the difference of perfect squares always will factor into their conjugates. So, some things to look at, and as we do these, to study. So when we FOIL these, it's x times x is x squared. Your outers, a negative 7x. Your inners, a positive 7x. Your last, plus 7 times minus 7, a negative 49. Your middle terms cancel out, and you end up with the difference of perfect squares. And if you see you have the difference of perfect squares, this will factor into its conjugates. And here they're showing you a slightly different version of what I just did. This is the rule for difference of two squares. A special way to multiply using the FOIL. If you're multiplying conjugates, the middle terms cancel out. Now, a good thing to know is to recognize at least some of the perfect squares. So, as you go, 1 squared is 1, 2 squared 4, 3 squared 9, 4 squared 16, 5 squared 25, and so on and so forth. If this is going to be useful for your notes, put it in there. So, do we have conjugates? Yes. So we don't have to worry about multiplying the outers and the inners. It's just x times x is x squared, negative 4 times, I should say positive first, times negative is a negative 16. Perfect squares. Alright, try this one. So 9y squared minus 49. Now this one's a tad different, but similar. Because they're conjugates, there's no middle term. So x to the third times x to the third is x to the sixth minus 36. Now, another special product is what we see here. Let me go over it with you. That if we were to take x plus a, and since this binomial is squared, we could do it this way. X plus a. And if we FOIL this, our first would be x squared. Our outers would be plus ax. Our inners plus ax. And our last plus a squared. Now here, again, as part of our special products, when we are squaring a binomial, notice that our inners and our outers are the same. So in the sense, we double this, and we get x squared plus 2ax plus a squared, which is what they're showing. Now, these, once we square a binomial, the trinomial that results has a special name. So when you square a binomial, the product of it is this trinomial, which we call perfect square trinomials. So again, a word for your vocabulary list, and may be a good question. When you square this and get this, this has a special name. What is this called? A perfect square trinomial. Now, here we're squaring the sum, and here we're squaring the difference. The only difference between the two is the middle sign. And the first and last terms are always positive. But depending on what was the middle sign in this binomial, that will be the middle sign in your trinomial. And if it was negative, this will be negative. Okay, a little background, and let's have some practice now. So we want to square this. And by the way, this is a useful technique for something you're going to use in your next course. The special way to do this is you don't write it out twice. The rule is you're going to square this, which is 4x squared. Now you're going to multiply these two together, which is 6x, and then you double it. And of course the middle sign comes from right there. So 6x doubled is 12x. Then you square this term here, and that gives you a 9. Now, a fallback, of course, would just be 2x plus 3 times 2x plus 3. When you do your first, that gave you this squared. When you do your outers and inners, this gives you the product of these two, but doubled, because there's 2 of them. And then squaring the last term here, this times this, squaring this gives you the 9. So again, a special product. I really like the way you've done this. So you're squaring the first term. You're doubling, that's the 2 here, doubling the product of these, and then squaring this. And you get that. Alright, let's try this one. Square this. That's going to be 25x squared. Now multiply these two together. That's going to give you a negative 5x. Double it. A negative 10x. Again, keeping in mind that'll be the sign of your middle term. And then now squaring a negative 1. Negative 1 times negative 1 is a positive 1. And there they're showing it in detail. And there's your perfect square trinomial. If you recognize this, it's going to factor into this. We'll be doing that here in the next few lessons. So let's try this one. Square the 9. That's 81. Multiply these two together. That's a negative 9x. Double this. A negative 18x. And then square a negative x. Negative x times negative x is positive x squared. They laid it out for you. There's the doubling. And there's the answer. This is a perfect square trinomial. Alright, take a moment and try this. Remember, as you take moments, you should pause so you have some time for writing. So we're going to square this. Now notice this is like raising to a power, so this is y to the 6th. Multiply these two together, it's 1 y to the 3rd, double it, 2 y to the 3rd, and then square this, plus 1. Okay. Now, again, I see this when I check the blue sheets, that often when students square this, they'll say, oh, I'll just square the x and I'll square the a. That is wrong, because you need to multiply these two together and then double it to get your middle term. Remember, the fallback would be to write it twice in FOIL, but once you master this, it's so much easier. Okay, there are some practice problems. This one went our 20 minutes. And there are the answers.